Anyway, up here we have Tom Brown. Tom, you want to introduce yourself?
I'm Tom Brown.
Okay, I'm Eric Cole. I'm the guy over here. We're going to be taking you on a whirlwind tour of the utility network. This one's actually kind of a strange presentation for us. We've been giving utility network presentations probably since the UC in 2011, and it's all been talk, cheap talk, lots of cheap talk. This is the first time where we've actually spoken about it when it's actually been delivered. It went out with 2.1 and 10.6, and it's all actually now out there in the wild as production software. Question, how many of you in this room are in production with the utility network right now? No one's in production.
What? We've been telling you for 5 years it's coming.
Okay, how many of you have actually tried using it in Pro with 2.1? Has anyone actually played with it? Okay, a few more people. Okay, very good, very good. So anyway, yeah, it's been a long time coming, but it's out there now, and we're going to be spending the next few years enhancing it and doing other things to actually make it really, really top-notch stuff. So you can, yeah, in any event, I better leave it at there. It was spiraling downhill very quickly. Okay, what is it about? It's basically technology to allow you to model, edit, and analyze complex networks of facility infrastructure across our entire platform. This is a very important thing. It is the first data set type that we've developed that really is truly cross-platform. It runs across it will ultimately run across the entire ArcGIS platform. In order to do so, it must be usable as a service-based architecture, okay? It's sitting up there in ArcGIS Enterprise. You interact with it through services. Once you have a service-based architecture, then you can light it up both through the Pro desktop as well as devices as well as web clients and all the rest, okay? That's another fancy slide showing the same, graphic showing the same thing. One of the big things we're doing right here is we're trying to enable a better and more accurate modeling of the real world. When the geometric network was released 18 years ago as part of 8.0 in February 2000, the world was a little bit simpler. We didn't have distributed power generation. We didn't have photovoltaics. We didn't have storage, distributed storage. You didn't have as much SCADA. You didn't have the AMI. You didn't have these smart grids, at least in the electric domain, that are autonomously performing switching operations to optimize the state of their networks.
You just described the Dark Ages. That's the Dark Ages. Was there even electricity then?
Kind of. Kind of. Remember those wheels with a burrow turning it around?
Okay.
Yeah. So in any event, yeah, we purposely developed this model. It's very aggressive to try to allow you to model at extremely fine levels of granularity the real world devices and infrastructure that you have inside your utility. Okay, it's not just points and lines and things that you've done with geometric networks. Traditionally, we actually allow you to model structures. There's a containment, there's all kinds of relationships at a very fine level of granularity in a scalable manner. So what are the key differentiators? Let's get through this stuff quickly. Cross-platform, okay. It's a service-based architecture. You don't interact with the utility network in client-server. It's all services-based. You're just hitting REST endpoints. Even the Pro client that you're running today is going through services. The Pro client is not backdooring into client server or anything like that when you're working with your utility network. It's all service-based. Have the updated network model. By updated, what did we add to it? We added all kinds of interesting things, such as being able to have connectivity associations, saying things that are not geometrically coincident or connected to each other. Being able to say things are contained within other things. Transformer units are contained within transformer banks. Pumps are inside substations or pump stations. Structural attachments. This recloser is attached to a power pole. It's structurally attached to a power pole, okay? Now, the interesting thing with the associations is they are part of the network index. You can go and traverse those things. You can see them when you're doing your network analytics. Support for multiple terminals. We learned that when you have things like transformers or sometimes valves, complex switches, that it's not just a point with all kinds of stuff going into it. It actually has high sides and low sides, upstreams, downstreams. So you can actually specify what terminal you want a line to be connected to on a particular device.
Maybe I'll demo that.
Yeah, Tom will demo all this stuff. But
All?
we're setting the bar, okay? But this PowerPoint right here is going to be much more interesting than any demo you can come up with, okay? I want to see another property sheet. Okay.
So Eric, you are moving very quickly, and I've noticed so far you didn't put the bullet in there for artificial intelligence.
I'm going to put the bullet in right here in
Is
just a second.
is that enabled yet in the utility network?
Not quite yet, but we are working on it.
Okay, good.
Yes, we will be in the long term. If you were just at the server road ahead session, in the long term, we will be working to get the utility network up and running on a distributed processing infrastructure as part of geoanalytics. That's one of the big long-term goals of this technology as well. But that's long term. Thank you for bringing that up, Tom.
I do have already a question from the audience. Does he have 100 slides again?
128, yes. More. Okay, expanded tracing framework. This is actually one of the cool aspects of this technology, is that previously with the geometric network, when you wrote tracing operations, you had to do a bunch of forward star cursor stuff. You had to walk through the network graph from first principles. That was pretty tricky stuff. Here we've actually created a framework that you can configure in order to do some very sophisticated analytical processing of your network. Tom's going to demo some of that stuff.
Actually, I'm not, because we had an outstanding demo theater yesterday, which everybody attended.
No, they didn't. Who here attended the demo theater?
That's at least 80%.
No, that's 7.2%, Tom. Let's see, built-in support for network diagrams. This is a key capability where we saw, particularly in Europe, people like to be able to edit and visualize their stuff in logical space, not just geographical space. So right now, diagrams and schematics are first-class citizens. Just as much as geographic space is, you have your logical space, and it's all built in. Validation framework, okay, that's for building and maintaining your network index. Source management, basic source management, okay, that's for figuring out where the resources flow, where are the origination points within your network, where do things move outward from. Let's see, what other things do we have? Export capabilities. We're working right now to provide enhanced export capabilities such that maybe you want to export to SIM, or maybe you want to export to multi-speak. Well, what kind of infrastructure can we provide that'll make it very easy for our business partners and others to actually create those adapters and whatnot so that you can do your SIM extracts or your multi-speak extracts. Updated transaction model, brand new versioning implementation called branch versioning. It's a lot simpler, and it's a lot more scalable and a lot more performant than the old traditional versioning.
That's a lot of promises.
Yeah, it is. It is. But it's good stuff, actually. Working with the team back in Redlands, it's very nice. You don't have to do any joins. You don't have state lineages. It's a very straightforward system.
You don't have to compress.
That's even better. Better yet, a lot less administrative overhead as well. And it's all based upon transaction timestamps, okay? Attribute rule framework. This is something that you're seeing actually across the platform. It's not just a utility network thing, but we're actually providing the ability to create rules using arcade expressions to either set attribute values while you're editing based upon other fields or other features, being able to check that a feature is satisfying various constraints before you store it. If it doesn't, it will fail the store operation and report back your error message to you. As well as in the longer term, we're working on a new validation framework. How many of you have used ArcGIS topology? Okay, about 98% of the room. Well, the validation framework is going to be based upon the topology model, okay? Where basically you're going to be able to author topology rules using arcade expressions. There will be dirty area management will be exposed, and then periodically you can choose to validate portions of your data set. If errors are detected, error features are created and they're persisted, and you can then go in later on and identify the errors and fix problems in your data. Okay, we're going to be trying to do a grand unification as well, where we're going to bring together the topology validation, the network data set, our transportation network model validation, the utility network, data reviewer, all the things inside ArcGIS that are doing validation of rules that you specify into one coherent framework, one general user experience. Okay, so you're going to see a lot of nice work being done in that domain this year.
Do you ever take a breath between statements? No.
No.
Remind me to demo the attribute rule constraint
Next time I'm going to bring an
violation.
oxygen tank and just feed it into my nose, and then I can really speed up. Okay.
Any questions up to this point? We have to constantly interrupt him so you can just relax for a second.
Okay.
What kind of validations are you looking at, like loops or?
Various different things. You'll be able to do topological, geometric, attribute, things that you see right now through, like, look at Data Reviewer. Data Reviewer exposes 40 some odd different rules. You'll be able to do the validation that you can currently do, typical operations you can do with Data Reviewer, as well as things such as, if I am contained within this particular land parcel, I want my identifier to be set to such and such. We're not going to be supporting a mechanism that will allow you to do full traces through this validation framework. We don't want you to be authoring a collection of rules that will just completely destroy your servers and stuff like that. These are rules that should be very quick to execute and things like that. So we're sorting through all that, but you'll be able to do some basic topological validation as well, okay?
To clarify, the concern about once you start adding all these attribute rules, they are fired at the time of store, the call to apply edits on the feature service. So it's happening at the geodatabase level behind the feature service. So just imagine the more rules you keep on adding and all this complexity, all it's going to do is slow down the edit operation, right? So there's truly a balance that we have to all take into consideration of what logic do I want to enforce at the time of the edit, as opposed what post-processing we can do or validation at a later moment. So it's a trade-off.
And one of the things we're looking at to help you identify when you do really silly things with attribute rules or these validation rules in the validation server is put in telemetry that will tell you how much time is being spent executing these or evaluating these rules, as well as perhaps putting in timeouts into the system where if a collection of rules exceeds a certain threshold, it stops and reports back an error to you saying you're just too slow, you got too much stuff coming up the works. So that is a very important point that Tom raised there. Okay, there will be subtype layers, better ways of working with the data inside Pro, as well as, of course, centralized storage of maps and projects through your ArcGIS enterprise. Now, trying to build a better framework, that's what this is all about. This is what we've been doing for the past 6 years. If you look at our current solution, it's shown on the left in that little diagram. At the bottom, you have the core desktop. On top of that, you have partner solutions. Then you have client customizations built on top of that, with the geometric network and versioning and replication being part of core. Okay? Now, what we're trying to do today is we're trying to expand the core GIS platform, the core ArcGIS platform, to include both the network model as well as versioning, as well as analytical frameworks, attribute rule frameworks, validation frameworks, better network editing tools. That's going to be just all part of core. On top of that, the solutions team will be editing or creating some foundational data models. You can see those today on the solution pages, as well as better collections of map and app configurations that you can download and utilize. Then we expect our partners, and there are many of them in this room, will then further extend that by creating very specific or customized domain data models, very specific domain-specific tools for doing things like circuit management, phase management, more validation rules, more analytic configurations, as well as more attribute rules, more productivity tools, things such as being able to do a SIM export. And then finally on top there will be client customization through configuration. Okay? So that in one little picture tries to detail how we're expanding what we're doing at the framework level and how we expect partners as well as the solutions team to build on top of that in order to develop and deliver more sophisticated capabilities to you guys. Okay, utility network consists of one or more domain networks. You can see we have 4 different domains here: telco, electric, gas, water. Everything has a structural network. Every utility network, every domain network inside a utility network, or every network inside every utility network has a structured network.
How's that telco network coming along for you?
It's going great.
That's our disclaimer. We don't have a complete telco model implemented yet. That's
You will
coming
real soon. Real soon now. Yeah, and we're the same people in 2011 said, it's coming real soon. 125 man years worth of development later.
Your street cred is worthless.
You know, it's been my life. I have a family. I have no credit home either. It's just like, whatever. Do you think I care? No. Okay, then within each of these domains, you can have a collection of other different types of networks. So for example, and these networks are used to organize the content of your network. They're relevant for your business units and whatnot. Maybe you want to have transmission and distribution separately. Maybe you want to have them together. Do whatever you want. So within water, a water company might have a water network, a structural network. Maybe they also have a sewer network. Gas company, okay, gas distribution, maybe they have a gas network inside there. Electric company, maybe they have a transmission network and separate the distribution network from that. Telco network, well, they have the structural network, but they also have their fiber network, okay? You can slice and dice it however you want. All these different types of networks can have other domain networks. And also, inside pressurized networks or buried pipe networks, such as water and gas, you may want to have a cathodic protection network, okay? So these are just little example ways of how you can configure your system.
Demo?
Yeah.
Wow. I was going to say,
number 5?
yes, please. I was going to say, for all of you taking photos, it's hashtag UN. It's a large following of people under that hashtag. So push those out. United Nations. All right, you will get all these slides in the presentation being recorded.
We should wear blue helmets next year.
And vests, white vests. The UN team has arrived. It is the Dev Summit, so I'll start by just showing the services, right? I can't tell you how many times we've said it's a services-based architecture, right? Did you cover any of this in the server session?
I don't remember.
Okay.
No, we didn't.
Okay, good. Because when you do publish your map, right, if I quickly pop over, here's my pro session, right, my pro map. If my map was all of my layers in the client server, when I go ahead and publish this thing, the sharing model in the pro user experience, maybe you attended some of those sessions, you have the choice to enable the version management service. And whenever the UN layer is present during publishing, we automatically create the utility network service and the diagram service. So these are all these new services that we've been building apparently for 5 years. What I'm just going to quickly show you is the utility network server, right? So when you go into, you see your services, you can pop in there. On my nice little surface, I've got 4 socks running, min 4 socks, max 12. I can go in here and see the capabilities. You can see then what services are enabled automatically. The nice note to be aware for the administrator, the version management one cannot be enabled or disabled through Server Manager, because when we publish and you want a version management service, there's a lot of little things, analyzers, that we run to verify that what you're publishing is everything configured correctly. But for the utility network service, right, we can go in there, get to that endpoint that just takes us to all the different operators. Now remember, right, in the good old days with ArcMap and ArcObjects, Eric would build all these internal IMPL interfaces on these COM objects that he could call through the application. Well, we can't do that anymore, right? Pro is calling every REST endpoint that's available, right? There's no secret sauce we can do anymore on the client side because we have to call the same public endpoint. So everyone...
That's a half-truth, Tom.
That's a half-truth?
Yeah.
Come on, go with the story.
Okay.
So, right, we have the UN. We can do traces. You know, this is what I was highlighting yesterday, how you configure a trace configuration. If you would attend these demo theaters or attend Rich's nice session that was prior to this one, he had great examples of trace configurations, right? So I'm not going to repeat that story a third time. Validate network topology is a very interesting one. I'm picking on this one because Eric did some outstanding work at the very end of the release.
What?
Yeah, one time you've done outstanding work.
You're such a tool.
To support asynchronous calls. Now, why I'm choosing this is so you kind of understand this, because Rich also made a reference to this in the session this morning. Who saw Rich present? So at least a handful of you came there and stuck around, so that's good.
Everyone else was at Sherman's.
Yeah, they're still having breakfast. So when we validate, right, when you validate from the Pro UI, what's happening is we're calling the REST endpoint directly, right, calling that validate endpoint, but it's an async false, meaning we want that to run as part of the SOE of the feature service, so it's running on the main SOC. It's going to hold that SOC. And the expectation there is that the workflow of a user doing this is you're validating a small area, and you want a very reactive response. Now, why we had to build the async and why we're going to be adding this to several other tools as well. When you call validate in the current release from the geoprocessing tool, it automatically goes async. So it's calling this REST endpoint, sets async true. When something is run async on the server, right, it's spinning up through a different geoprocessing tool, and it's running a job, and it's processing all the work there. So you can imagine just that load of taking a job, spawning it off, running that. You have a toolbox in, I won't show you. You have a toolbox already there with a special UN tool that will run these as you need them. You want to do that when you're in a workflow that you're validating very large areas, right, with a lot of dirty areas. Because it's going to take a little bit of time. You don't want to hold the main SOC and compete for the shared resources that all your other users who are displaying data, querying data, tracing data.
Do you want to talk about timeouts a little bit?
Yeah, I will. That's another good example. If you were to click the Validate in Pro because it's running synchronous, you are constrained to the typical server timeout, which is 10 minutes. Right? I can't remember, 5 minutes or 10 minutes? 5 minutes? Anybody want to vote on this? 5 or 10? But it's a setting because you don't want to hold that SOC process so long, right? Because it's in a shared community, right? We have to share these resources. That's why we have async. So keep that in mind, what we'll be doing. Hopefully, if Eric does more good work.
Actually, it is 10 minutes. You're right,
it's
by default.
600
600 seconds.
There you go, quick math. What we'll expose on the GP tool is a checkbox to either run validate in a synchronous or asynchronous, because you guys know the workflow of what's happening. Because again, we want to provide a framework and configuration of all these tools, because based on the workflows, the users, you know, if you poured a whole bunch of data in, you know when you need to run this asynchronously in the background. Now, here's the trick though. When running the geoprocesses tool, even though it's running asynchronously on the server, we actually spin on the client side, and that GP tool will just sit there and spin. So from that perspective, it's a synchronous type of call, but we offload it to an asynchronous job. So that will be the pattern that we follow in a lot of these other tools, because we really don't see the user experience of somebody sitting here clicking these large validates or update subnetworks all and just, hey, I'm going to watch this tool until it completes, right? So, all right, that was just a ramble to kind of show you some of the more details of the service architecture. What else am I supposed to demo in this section?
Let's see. How about a property sheet?
Okay, that lovely property. But I'm not going to talk to it that long. Again, so here's my map that's already published. One of the nice things, just to give you a quick example of the high-level properties of the utility network, right? There's a lot of configuration that goes involved of how you want to configure and deploy your utility network, right? We have these great things called asset packages that are available from download for the various different domains, right? Those are great starting points for the different, water, electric, gas, and so forth. But again, it's a starting point. Many of you will configure it based on your needs, or business partners will build their own asset packages. Like if somebody wants to build a steam network, very common in Europe, apparently. Mm-hmm. So when we open up these properties, right, this is where we get to see the makeup. How was it configured? When was it created? One of the things we listened to you for many years is, hey, when was feature class created timestamps. We're trying to timestamp a lot of these configuration properties so you can understand, hey, I deployed February 1st, 3 months later I added a rule or I added a subtype, which is the asset group. I changed something because you are logically redefining the configuration. So when you go back in time, you have to understand how things evolved.
And we'll be adding a lot more temporal metadata to the system as we move forward. It's not complete yet.
So as Eric highlighted, the data set I'm working with has 3 domain networks, a structure network, a transmission network, and a distribution network. And it's all about rule-based, right? That's a very important aspect of this model because, again, representing the real world, we have to define the rules of how things can logically connect to each other. It's either a pipe size traversing through a connector. They must be the same size and so forth. Or how connectivity associations work between a voltage regulator and a bypass switch. I'll show you that example in a little bit. And that gets into terminal configurations. So this is really the heart of the information that describes your utility network. It's a good starting point to understand what these models provide and what you can do. Anything else on your list? Or you want to go back to slides?
That's good.
All right, let's go back to slides.
Okay, let's see.
Any questions? Questions?
No, none.
Wow.
Okay, we're one.
Back a little bit. You mentioned the water network being used potentially for wastewater as well. Is there a plan to have separate networks for wastewater, stormwater, or will all that fall under the umbrella?
You can do whatever you want. You can
Well,
put them
actually,
all.
you can't, Eric. I wouldn't want my wastewater combined with my drinking water.
No, he said stormwater.
I heard wastewater.
No.
Well, I was talking about both because we manage both. Will there be
Yeah.
asset packages developed for those?
There are.
domains?
There are asset packages coming for each of those domain networks. And what's very important, so you understand, a lot of the examples that we demonstrate with electric, gas, and water are all source-based networks, right? Wastewater being a gravity model is a sink-based model, which is all there in this release of the utility network. So that team is working on finalizing wastewater and stormwater. I think they were talking late spring. It's coming.
And even if your sewer network, which is essentially a sink-based network, you can still have pressurized sewer in it. It's pretty sketchy, but yeah, you can. I wouldn't want to be near that pipe.
We got some of those.
Good. Lucky.
Water main.
Makes San Bruno look like a walk in the park, right?
Slide.
Let's see.
Session's over at
half
10:30.
done. No, it's over at.
That's 2 more minutes, right?
Oh, good. Good. Let's see. We're half done with time, and we're a quarter done with slides, and 1/10 done with demos.
Skip slides.
No, I was just going to say, would you guys like to stay here till 2:30 or so? Is that working for you? Okay, well, let's just get through these things. Connectivity associations. Basically, this is, think of it as basically a way where you can say this point is connected to that point and they're not geometrically coincident. Okay, you don't have to be, by default, things are based upon XYZ coincidence. It is Z enabled. It is a 3D based network, but you are able to say that these things that are physically not coincident, unlike the geometric network, are connected. These connectivity indexes are become part of the network index, so you can traverse through them and all that. Okay, it's not like a relationship class. It actually is indexed within the network itself. Okay? Blah, 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 blah. Yeah, we said that. Yeah. Okay, containment associations. This is a way to say that this particular thing is contained within that thing. For example, to say a valve is inside a pump station. Or if you have a substation in electric, maybe you have some transformers and bus bars and fuses and all kinds of stuff like that. That can all be represented using containment associations. Okay? Structures and assemblies can be the containers. The devices cannot be containers. They can only be content. Okay? Now, the interesting thing with containment is you can have nested containment. You can say this thing is contained within that thing, which is contained within this other thing. Think about a duct bank. A duct bank is a container, linear container. A duct bank contains many ducts. Inside each duct, you may have many lines or fiber cables or something like that. Within those fiber cables, maybe you have fiber strands, okay? So you can create these large containment hierarchies if you need to, using containment associations. What else? Structural attachment. That's much like containment, but sort of used for above ground. You can be able to say that this particular thing is attached to this other thing. For example, a transformer being attached to a power pole, okay? And this is nice because, again, all these associations are indexed within your network index and can be returned as results to your analytical processing of the network if you feel the need. Let's see, terminals. Terminals are basically used to represent a connection point on a device. Here we have a transformer unit that has a high side and a low side. Now you can actually model that using a device that has one high terminal and model it using two terminals, one high side, one low side. You could, if you saw the need to in your organization, to model it as a device with four terminals, one high side terminal and three low side bushings. As you can see inside that picture, it really does have three low side terminals in reality. Model it any way that you want, okay? It's very important to be able to do accurate sim extracts as well. Now, what are the rules here? Every device doesn't have to have terminals. It's only the ones you want. But if you are a subnetwork controller, something that functions as a source or a sink essentially inside your network, you must support terminals. Also, if things have high and low sides that you need for analytical purposes, or things that have one-way flow, such as a check valve in a water network, okay? Bypass switches. Okay, now this is interesting, where you can represent a bypass switch using a device with four terminals. Okay, here we have a sort of a logical representation of a bypass switch that contains two disconnect blades and a bypass blade that are all coordinated, and it's connected to a voltage regulator. So when the voltage regulator is in service, you can see the black line on the top. Power goes from, say, left to right. It goes to A, through the disconnect blade to C, through the voltage regulator over to D, up through the disconnect blade on the right, through B, and outward towards the east, okay? Now, when a device is de-energized, you can then safely remove it and all that. And these things actually...
I don't think they picked up that cool graphic.
What?
Yeah, that.
That's
pretty cool.
Yeah, I only spent 2 weeks on that. PowerPoint animation.
Can I trump you on that?
Go ahead.
No, we're not going to talk politics. I just said trump you on that diagram.
Yeah, okay.
So here is actually how we're going to document this. So we've got an author, Michael Zeiler. The guy's a wizard at making nice graphics and pretty pictures of how the software operates. So we're going to try to make instance diagrams of all these different configurations, right? And how they would represent the real world. So this is an example of a voltage regulator bank assembly where there's three of these. Where he's showing we've got the bypass switches here in the middle with their four terminals, just as Eric just described it. We've got the voltage regulators on this side with their terminals. So as we come in off of the overhead line, for each phase is connected to each one of these individual regulators. Now below this is showing the properties of the bypass switch, exactly what Eric showed, right? The path, when we want to bypass those, allows us to just flow through the switch and onto the line, as opposed to when the switch is closed, it then goes into the regulator. If we can only have those cool little moving arrows.
Yeah, I know.
On
Where's the animation?
Yeah, no animation.
That sucks. Are you done?
No, I want to actually show it. PowerPoint's a real software. Come on. I put this together for you.
PowerPoint never crashes. You have a 50-50 chance with this one. Come on, do it.
And for some of those who are sitting next to me in the last session, realize I downloaded this morning's build. All right, so
that's the liquor talking, okay?
Hey, come on. We're all software developers. We got to show this stuff.
30%.
Okay, here we go. We've zoomed in along this overhead circuit, right? Here's the voltage regulator assembly, right? So it's not showing all the content. So first thing we'll do is we'll display the content, because now I want to work within the features in that assembly. So as the diagram showed, the nice pictures, we've got a bypass switch for each of these, right? It's a switch, overhead, bypass. If I opened up that properties page, I'd be able to show you the terminal configurations and the different paths that it supports. So we have one for each of those phases.
Can you show the connectivity associations?
Oh, that's a great idea. And we also have ground terminals, and we have the platform, because we've got 2 poles supporting these all up in the air with a platform between them. They're all attached to the platform. The overhead lines are attached and terminating at the poles themselves. And as Eric said, we can turn on this new tool, the View Associations tool. So right now it's a bunch of spaghetti, a bunch of lines. But we'll talk about this. So the brown color represents a connectivity association. The green color represents a structural attachment association. So a quick way to visualize how things are configured. Now, at this release, you don't have a choice to pick those colors, so I hope you're not colorblind. We are working in the 2.2 release to allow this configuration of my associations and what colors they will be used. So we're getting there. It will be in 2.2.
It's a significant enhancement.
Yes, it will highlight that as one of the major new capabilities of the UN. All right, let's now actually trace this subnetwork. Let's see what we get back. Where's my tool? I'm going to come back and highlight more of this subnetwork tool, but it's a very quick way to find the subnetworks in the current visual extent, and then I can quickly trace the subnetwork. And this is just doing the subnetwork trace. Wow, that is fast. Tracing the subnetwork based on its configuration. Now, one of the things you'll notice, because I know when we don't have flow arrows yet, will that be a significant enhancement to the utility network?
Second release.
Okay, sorry, maybe third release.
That's a bridge too far.
So just so you know, the power, the electricity is coming from this upper side. So we're flowing in, and we enter this bypass switch. The state of this switch is closed, allowing it to flow to the regulator. The regulator then, of course, flows back to the bypass switch for this phase, and these are all labeled based on what phase they are, so this is our C phase. And then that connectivity association brought it back to this line end. Now these bypass switches are currently open, right? So it essentially has a connectivity association from the line end to the switch, but it does not connect to the regulator. Then it simply proceeds on bypassing the regulator. That allows them to do service on that device in the field when needed. But how do I quickly show how we can change the paths? So we have a tool called terminal paths. And when I actually select a switch with a device, oh man, where'd that tool go? It will show you the current state of that path of that bypass switch. It's open, but we want to actually close it. Now, terminals and paths have default configurations. The default path is closed. So whenever I create a new bypass switch and place it on the map, essentially the default path of the terminal configuration is closed, allowing the flow of that commodity through that device. Because you'll want to say, well, 99% of the time it's closed. I don't have to go back and set it as I edit. All right, now as I hit apply, you'll see that it creates a dirty area as it creates the dirty area, because I've changed an important attribute that's needed in the topology of the feature. Not all attribute changes on a feature will create a dirty area. Only things like the path configuration, if it's a controller, if it's a network attribute, the shape, right, you modify the geometry. But if I touch some attribute that has no meaning to the topology, no dirty area gets created. So I should have clicked validate as I continue to ramble. Any good comments as you're checking email?
No, I checked out of your presentation a long time ago.
I haven't crashed yet. Okay, this usually takes about 10 seconds to run that validate. Now, what's very interesting, another sidebar discussion as I wait real quickly, I'm editing in the default version. What's really powerful about our branch versioning model is we support 2 ways to edit the data. If you go directly against the default version via the REST endpoint or via Pro, it's just like any other feature service. When you call apply edits, those edits are burned in. They're written. There's no rollback. Now, apply edits calls do have a new argument called rollback on failure. So if an error happened, like a check constraint of an attribute rule, the entire payload of the apply edits is rolled back. Now, why did we do this? We did this because there are two different transaction models where if you either want to quickly write to it or you know you want to create a name version. When creating a name version, it provides me the undo redo stack. So in Pro, if I had created a version, changed to it, and applied these edits, these would have all have been individual edits that can be undo redo, right? Everyone follow that. Say, brilliant. All right. So now let's clear this. Now let's repeat my trace. Go back to my Find Subnetworks tool. This is the shortcut, so I don't have to pull up that monstrous geoprocessing tool and set all those parameters. This is the nice part. Now, wow, look what just happened. That trace coming in, because it went into the B phase, now includes the voltage regulator, because the path was in there. God! Let's just go home.
You get a golf clap for that one. Jeez. That was a lot of talking to light up one more blue dot on the screen.
The takeaway is just the amazing power of the utility network.
Takeaway was mumbo jumbo.
That could have been a valve with 4 different connections. It could have been a switch.
Yeah, okay, so anyway, we've been talking a lot about electric devices and whatnot, and you saw it. Devices and switches like that, but then in the water domain, of course, a complex valve can be considered a switch as well. Here we have an example where it's a dual flow 4-port diverter valve. And yes,
I'm counting more people leaving the room when you're talking versus my demos.
Free beer, everyone. It's over there. Okay, let's see. We have a little, like 15 minutes left.
I think we'll cover it.
Okay. Okay, 4-port diverter. Here you can see the flow from AB and CD. Okay, you go and divert it. It goes from AD and BC. Now you can represent it as a device with 4 terminals, A, B, C, and D. One thing that's important to note inside any device with terminals, inside the network index, we represent that as a complete graph, meaning each terminal will correspond to a junction element, and then we'll form a complete graph between all the junction elements inside the network index. Then, based upon the configuration of your terminals and how you want the switch configuration to work, you can then decide how you want things enabled or disabled. So, for example, when we flow from A to B, we'll just enable edge 1 and edge 6 in order to get it to work that way. Alternatively, switch it and you can do AD, BC by enabling different edges. Okay, and that's all taken care of under the covers for you. Subnetwork management. What is a subnetwork? That's a really tedious way to describe essentially a subportion of your network, these key subportions of your network. In the water domain, a subnetwork might be something like an isolation zone. Okay, or it could be a pressure zone. In the electric domain, a subnetwork could correspond to a feeder or a circuit. Okay, these are logical subdivisions of your larger domain network that you want to use. These are oftentimes used to drive your analysis applications, your tracing and everything like that, as well as labeling, annotation, doing your map making, assigning units of work where you do the tree trimming or pole inspection. As well as just being able to visualize it. And oftentimes working with third-party systems like distribution management systems, you need to be able to extract these subportions or subnetworks, okay, when they have been modified during the course of your editing during the day.
You
want to be able to export a subnetwork.
Chant. Demo, demo, demo.
Okay, we have about 10 minutes left. I hope it's a 1-minute demo.
This will be a 1-minute demo.
Starting
now.
Now.
Okay, so again, here if we zoom in a little bit on our data, electric again, I'm not going to switch over to gas networks. but a circuit map, right? All the individual circuits represent a subnetwork. On this Sempra data set, we essentially were given access to extract
45 seconds.
the old town substation to show all these subnetworks. And I think what's really cool is I zoom in somewhere here, and then I bring back up that other tool that I had used before called the Find Subnetworks tool. I can actually refresh that and quickly visualize all the subnetworks in my current extent. Now, you'll notice that I
30
just
seconds.
showed the blue lines and not all the colored oh, I'm losing time because I can't talk. What we're actually doing here is showing an aggregated geometry representation of that subnetwork for much better display performance. And off of this tool, I can actually go and actually pop up individual subnet things, and I can see different properties that show counts about the subnetwork. Questions?
You're going to have an
Back to
aneurysm right
you.
now. Okay, tracing. We talked about this a
demo.
little bit. I thought it was great. I got it all. Tracing is exposed essentially as a GP tool. It's also exposed through our services. Everything is exposed through services inside this system, okay? There are REST endpoints that you can hit directly and all the rest. Now, the nice thing about tracing is it is a framework. If you look at the GP tools that we have inside the utility network toolbox, there's only one trace tool. There's not an upstream trace tool. There's not a downstream trace tool. There's not a loop detection trace tool inside our GP tools or a REST endpoint. There's only one trace on the REST endpoint. There's only one trace tool, but it's incredibly highly configurable. Are we going to give a demo on that?
No. Can I take this phone call?
That's your grinder feed. What's that?
Okay, come on, focus. We're running out of time.
Okay. Network diagrams, that's our mechanism for allowing you to get a schematic or a logical representation of your data. It's very easy to use and configure. As we move forward, you're going to be able to see more and more editing capabilities, including being able to edit the attributes of the associated features from within diagram space. The holy grail, of course, would be able to do feature creation within network diagrams. I'm sure our crack development team is working on that one already. But you can do your white space management. You can go and rearrange your diagrams. You can configure these things very heavily. You can create new layout algorithms. It's a very nice framework for managing your schematic or your logical representations of your data. You can also set up, when you define tiers within your domain networks, for each subnetwork, you can have a schematic diagram created or a network diagram created automatically when you're updating your subnetworks, okay? So you always have a consistent logical representation of your subnetworks inside the system. Yeah, I said all that. I said that again. Let's keep going. Validating. Validation of the utility network is much like a topology validation. It's following the same model. Basically what we're going to do is during the validation process, we're going to go and tease apart all the geometries, all the associations, look at the rule base. We're going to then establish connectivity, go and index the connectivity, index the associations, the containment, the structural attachment things, and we're going to go and tease through, look at all the rules that you defined on the utility network for managing what constitutes valid connectivity or not. If there is any ambiguity or you're trying to connect something together that should not be connected together based upon your rule base, we'll throw an error, such as trying to hook your transformer to a pressurized sewer pipe. That will generally result in an error when you do a validation, if you properly configure your utility network. When rules are violated, we're not going to fail the process. What we do is we end up creating error features that you can then inspect and figure out what's going on with your underlying network and correct them. This is much like the ArcGIS topology experience. And as we were saying earlier, we're trying to do the grand unification of the validation rule framework, the validation framework, to make topology, network data sets, utility networks, data reviewer, everything have a similar look and feel, a similar workflow, okay? They're all very similar, but a little bit different. We're trying to bring them all together. And so you'll see a lot of interesting advancement in this domain through the course of this year and early into next year. Transaction model, we
already talked about.
Yeah, it's all new. Branch versioning, you can do high isolation editing, much as you can today, as well as short transaction editing. Tom talked about that earlier. Okay, benefits, no need to reconcile and compress. Tom talked about that earlier. And good performance, and you do have temporal capabilities. You can go wind back inside time. Attribute rules, okay.
I have a demo for this.
Oh, I bet it's a great one.
Okay,
Let's
go on.
stick to PowerPoint. Let's see, attribute rules are used, they can be used right now, calculation rules for populating field values, such as field A is equal to the value of field B concatenated with field C with 2 colons in between. You can create arcade expressions to configure these attribute calculation rules in order to do this when you're editing your data. You can also create rules that will determine whether or not the feature is in a valid configuration. You may say that field A must be equal to 10 times field B. If it's not, throw an error when you're trying to persist it. That would be an attribute constraint rule. And those are all part of the existing product. We're working very aggressively to extend the arcade language to incorporate more capabilities, such as being able to do searching. If I'm contained within this other type of feature, do something different. Okay? And arcade
Demo.
is intended to run across
Demo.
the platform.
Demo.
You will see it running both in
Demo.
the Pro desktop. You'll be able to see it running in GeoAnalytics. You'll be able to see it in the Portal web map viewer. You'll be able to see it ultimately inside runtime and mobile. And you'll also be able to see it in online at some point in time. It's basically our language that's going to allow you to do cross-platform scripting. It's very much like JavaScript, but it's not JavaScript, so we don't have the security problems. We actually fully control the language, and we can make it run safely in multi-tenant databases. Types, calculation rules, and constraint rules with this release. Yeah.
All right, I'm stealing the. Perfect. I'm stealing the projection. Okay, here we go. We're going to zoom into this little area. As we said, we're modeling the real world. So I've zoomed into a location where I've got a collection, fuse assembly with the individual fuses that are tapped off of this overhead line. So we're going from a 3-phase overhead down to a 2-phase overhead, as the label indicates. So what we're going to actually show is just the attribute rule constraint behavior. So if I select this feature, the label again is indicating that it is a B-phase fuse. As we know, fuses in the real world can only actually protect a single phase, not multiples. So therefore, I would like to enforce a nice attribute rule or constraint that says the value for phases current must be a value representing a single phase. Now, we have a domain assigned to the phases current. That domain has all the potential 7 combinations of phase potential values here. So if I go ahead and I click on BC, but I'm not going to click yet. The reason why, I've got to have a disclaimer here, I'm running 2.2. And this is actually the first time I've tested this because the editing team installed this nice optimization.
Good luck.
With 2.1, anytime you would do an edit, this is Pro, right? It would pass that as an apply edit to the feature service. As described earlier, that's where the attribute rules all kick in at the geodatabase behind that feature service. So you can imagine every time you're editing in the Pro client, it's just passing those edits. Oh God, an attribute rule failed. Comes back with the error telling you it failed. That's a pretty wasteful round trip just to find out that it failed. That forces the user to redo their edits with the appropriate values. Now, this is pretty cool. Now, the editor says, hey, as you are editing, I am evaluating the rules assigned to that class. So immediately, when I click on that value, nothing has gone to the database. You can see the error that is presented. That's kind of, you're not even paying attention anymore. You can see the rule, violated attribute constraint rule. And as one who defines the rules themselves, you get to specify the error number, because if you're doing something programmatically, you may want to trap for that error number and do conditional logic, and then return the error message you feel is appropriate. Fuse phase's current value must be a single phase value. And then I'm showing A, B, C, de-energized, or unknown.
You need to find a grammar checker online.
Do you guys not like that?
Is that all you had?
Yes, because you've got more slides.
Okay, editing. Let's see. Editing, one of the nice things is, as Tom was describing there, we're having the editor team incorporate deeper integration into our frameworks to be able to detect these things very rapidly when you're editing the features, not just when they're going to store. We've also worked with the editing team inside Pro to allow them to better integrate with our metadata, to be able to set up the snapping environment automatically based upon the connectivity rules that you have specified, so that when you're editing, you can't snap and connect things together that shouldn't be according to your rule base. Okay, that's pretty nice. Let's talk a little bit about the service-based architecture. Okay, here we have a diagram on the top. We have the Pro client. We also have the managed SDK. That's what Rich was describing earlier this morning. Then that's all conceptually sitting up on top of the geodatabase on the client side. The geodatabase then communicates with the ArcGIS Enterprise through, of course, JSON, and it will hit the feature service. This feature service itself is exposed through a REST API, which will then sit on top of a geodatabase. The geodatabase on the back end is communicating client server to enterprise geodatabases behind the services, okay? Now, the feature service was extended, as Tom was describing, for apply edits to be able to support a more sophisticated transaction model as well. We've introduced some new services, the utility network service to do things such as tracing, subnetwork management, export subnetworks, all the key things that you want to do with a utility network. There's a network diagram service for building and maintaining and managing your network diagrams. That itself is a separate service, a new service that was introduced at 10.6 and 2.1. And finally, there's a version management service that can be used for other data set types. That's doing all things versioning, basically creating versions, deleting versions, altering versions, reconcile, posting, things of that nature, okay? Now, we fully expect our partners to complete the solution here. We don't have a complete solution out of the box. We provide a great framework that then you can work with the Esri solutions team as well as other business partners to complete the solution and do what you need inside your organization. Or if you're really good at programming, just do it yourself. You can, of course, roll your own if you feel the need.
5 years later.
Okay, moving to the utility network. Partners are key here, providing capabilities that allow you to migrate your data. We also are providing various different data models through the solutions team for things such as water, gas, electric, and you'll see more for fiber and other things as they come online, the capabilities. And there are various different pieces of technology out there to allow you to move your data across. Now, it's all about growing the platform. It's completely service-based. It's sitting on ArcGIS Enterprise, all the core. And so then you have the desktop, your devices, as well as your web clients being able to access those REST APIs. Now, although today we do not have like the JavaScript SDK for doing web app development extended to support the utility network directly, you still can write web apps that hit the REST endpoints. You'll just do a little bit heavier lifting. Hitting those JSON endpoints, we've seen people already being able to do editing and trace tools and tracing functionality through web apps. You can do it already.
Who read the really cool blog about how to do this in JavaScript?
That came out, yeah, like a week ago.
A week ago.
Yeah.
By
it's a good
Hussein.
one.
Very
Yeah.
cool.
Yeah, so just go look at our blogs. Shows how to do it in JavaScript, do tracing.
How many of you knew we had blogs? As we can tell.
Another epic failure. Okay, let's finish this thing up. Basically, it's all about building a better framework. What we do is we have at the bottom, we have the ArcGIS platform, enterprise, all that. We built the utility network on top, the framework on top of that. We then see the solutions teams providing utility network configurations, maps and apps and models and all the rest on top of that. And then finally, partners sit on top of all of that and complete the solutions for our end user community, for you guys. So we finished with a minute to spare.
Perfect. I can do another demo.
Oh, sorry, it just turned to 11 o'clock. No. No, if you want to give a demo, go for it.
I don't have any demos.
Oh, never mind.
But I'm willing to.
Okay,
but
any quick questions?
they're fleeing again.
Yes, they are. The banter kills people.
They've been held hostage long enough.
Okay, well, anyway, we'll be back at the island. Is the island still open?
Only your island.
Did they close it?
Yes.
Shit, I don't know. Well, sorry. Next year you can ask some questions.
That's Gilligan's Island.
Yeah, I know. Whatever, Skipper.
No questions, really.
Okay, any quick questions? Yeah.
On terminal device, can you define a custom graph?
No. No, you can only, it'll always be a complete graph, but you just can define what things are enabled and disabled.
You define the valid paths within the complete graph.
Yeah. Yeah.
In the public sector, with water sewer and everything in mind, we currently deal with isolations and tracings, but we hide the plant data. We just have it a completely separate feature data set. What's the consideration where that would be regarded with this network? We made the switch to go to the network. How do I secure my plant data while hosting out everything else to the whole world so that it's public free, public information kind of thing? Am I breaking anything by doing that?
Well, first, we would recommend that you pour the inside plant into the utility network because you can do richer analysis and better detailing. I'm sorry?
I can't argue against that.
Good, good. The second part is, personally, I would never put a production data set publicly accessible. I'd make a copy of that to share out. Right. But during that sharing model, so even you had a clone of your utility network that you're sharing for public interfacing, you can limit the access based on what web maps you share. So the web map could actually stop and not include the inside plant.